Okay, friends, welcome to day one of derivatives. Today we're going to introduce the power rule. That's Jim Carrey and Bruce Almighty, a great movie about his power and what he did with it. Anyhow, we're going to teach you about a calculus term called power rule, which is a way of calculating the derivative. So here we go. So today, by the end of this little video, you should be able to look at that and be able to calculate the derivative of that in about 4 seconds. So we're probably not there right now, so let's get into it. Okay, and we're going to be working on our communication as we always are in this class, and if you're interested, you can spend some more time clicking on that communication and look at the curricular competencies and begin those skills. So here we go. So you have already spent time with Newton's quotient calculating the derivative of 3x squared, and the derivative is 6x. As it turns out, there's actually a pattern with 6x and 3x squared. And if you look at these numbers, is there any way we could get a 6 out of those numbers there? And if you're like me, you're probably wondering if 3 times 2 is 6x. It's interesting. It is. Let's see if that pattern continues. So here we are, the derivative of x cubed. Now look at this. If you do all the expansion with Newton's quotient and you expand it all out, you get down to a derivative of 3x squared. Is there any relationship between x cubed and 3x squared? Well, this time it looks like it's 1 times 3, and it appears that we're going down by 1 in the exponent. Let's see if that continues. X to the power 4. When you expand it all out, you get 4x cubed, and you are very observant if you're noticing that it's just bring down the 4 to the power of 3. We won't do this. Well, let's practice this. What do you think the derivative of that would be? Just by guessing and checking. Did you get 20x plus 5? 10 times 2 is 20. 5, that's what it is. Let's take a look at this guy. Can you do that one in your head? Are you getting 30x squared plus 10x? That's what the derivative is. I'll skip these guys. This is called the power rule, and I'm going to walk you through this here. And so here's the derivative. This is called the power rule. If you have a function y equals x to the power of n, the derivative is n times x to the n minus 1, which you've seen in numerous places. What I'm going to do now is I'm actually going to prove to you that this is in fact true. So let's see how you do with this proof. So I'm going to expand and factor the first couple binomials here. So notice that's a minus b. They all have a minus b. How many terms do you see here? 2, just like there's a 2 there. How many terms do you see here? 3. How many terms do you see here? There's 4. How many terms do you see here? There's 5. What a surprise. And if we go all the way down to 6, what do you notice? There's 6 terms, and that's to the power 6. There's another pattern. Do you notice that this is a to the power 4, 3, 2, 1, and the b's are ascending, they're getting bigger? Notice that happens again. A5, A4, A3, A2, A, and none. And so if we were to ask you, what would it look like if this was to the power of n? You'll notice a couple things. First off, we should be clear about how many terms would be in this factored form here. There was 2 here, 3, 4, 5, 6, and so on. So here there'd be n terms. Also notice that the a terms are getting smaller by 1 each time, and the b terms are getting bigger by 1 each time at the exponential level. So what I'm going to do is we're going to fill this out using Newton's quotient. And Newton's quotient says this. If you have this function here, here's y2 minus y1 over h. And now what I'm going to do is I'm going to apply this understanding that we just learned here. Notice that in this form here, this x plus h would be like the a values in this expansion, and the x's would be like the b values. So a minus b, or in this case here, x minus x plus h, and there's my b. So a minus b, a minus b. Now, when we look at this expansion, this part right here, what will that simplify to? Well, you're right, x minus x is 0, so we have h over h, and those will cancel, won't they? And they do cancel, so now we're left with this. So in this expansion, do you remember how many terms are going to be in this part here? I think you said there's going to be n terms. That's really important. Another thing to observe As you see, as h goes to 0, this will be x to the n minus 1. As h goes to 0 here, this is going to be x to the n minus 2 times x, which would simplify to x to the n minus 1. That'll simplify to x to the n minus 1. As h goes to 0 here, we'll have x to the n minus 3 times x squared, and that'll go to the x to the n minus 1. How many of these will we have? Well, you know that there's going to be n of those. So rather than writing down this full expansion, I could just say that there's n of those things, and then I'd have n of x n minus 1s, which is in fact the derivative. So x to the n, the derivative is n x to the minus 1. You might want to watch that again, as that's the proof for the power rule. So then what we're going to do is we're just going to talk these through, and I think we can see that. So the power rule would say 7 times 3 is 21, and 7 minus 1 is 6. Right here, we're going to have 3 times negative 2 is negative 6. 3 minus 2 is 1. This is going to be 10x. And be careful here, we're going to have the minus 4 and negative 4. Subtract 1 is negative 5. And the derivative, that right there, will be a times n, a times n, and then n minus 1. Okay, now let's look at this one. This one's obviously more challenging. And so when we look at this one, in order to use the power rule, we have to be in exponential form. So this is not exponential form. So step 1 is just making sure that you know your exponent laws. So the square root of x equals x to the 1/2, and 1 over x to the n equals x to the negative n. So when we see 2 over the square root of x to the power 5, we know that it's going to, that this is this radical in exponential form. At this point now we just use the power rule. So the negative 5/2 will be multiplied by the 2, which we've just done there. And we're going to go negative 5/2 minus 1, which simplifies to this. And this is correct right here. It's an exponential form. But you should see that all of these are equivalent. They're all equivalent, and you should be comfortable leaving your answer in all those forms. On an assessment, I may say leave your answer without in exponential form, or in radical form, or in simplified radical form. You should be ready for that. Okay, let's look at this one. Determine the equation of the tangent line when x equals 16 on the function f of x equals 32. Okay, so they've said write the equation of the tangent line. Well, the very first thing you should be thinking here is, as soon as you hear tangent line, you should be thinking y equals mx plus b. And also, in addition to that, this equation has the same slope as the function itself at those key moments. So this function here has a slope all the way along its curve. I'm just going to show you what this looks like so you can see this graph, because it's a bit of an interesting graph to look at. You don't need to know how to graph it, but that's what it looks like. Can you see that every point along here would have a different slope? And so each of those would have a y equals mx plus b. So that's why I start here, and we're trying to figure out what the slope is. So the m value. Well, another way of saying slope is derivative. So if we take the derivative of this guy, we'd be in a very good spot. So, just to set this up, we'd have 32 x to the power of 1/4. When I take the derivative of this, remember this is, I'm going to call it y prime would equal 1/4 times 32 is 8, and then this is going to be x to the negative 3/4. Okay, so that's pretty interesting. Then the next thing that we're trying to figure out is, that's the derivative. Now we want to find the slope when x equals 16. So one of our skills is we want to make sure, do we know how to simplify these things? And I tend to leave things in radical form when I'm computing them. You don't need to, but I'm going to. So if we then went ahead and put 16 in here, let's choose the beautiful color. Remember, it's going to be 16 cubed, and then take the 4th root of that. What I want to do is I'm going to take the 4th root of 16, and when I do that, if I take the 4th root of 16, what I'm going to get is I'm going to get 2, and then I'm going to cube that. Okay, so the 4th root of 16 is 2, and 2 cubed is 8, and 8 divided by 8 is 1, which is fantastic, because then when I come back to Desmos right here, and I type in 1x, oh my gosh, look at that. That looks like the right slope to me. If I move this line in why isn't that nothing? Oh, I see. The numbers are too big, too small. I mean, so let me just. Oh, why is it like that? I see. These numbers did not. Okay, let's see if I can do that. Okay, I got to make. Excuse me. Let's go 100. Let's go negative 100. This should give us a better movement. Okay. Okay, look at that. So we can see that is in fact the slope. So we know that the slope is 1, as we've just observed. Basically, at this point, we know we could rewrite this equation right here as y equals 1x plus b. In order to find the y-intercept, what we're going to need to do is do a couple things. One is if we knew what the x value and the y value were, we could find b. And that's exactly what I'm going to do. So I know that x equals 16 plus b. I need to figure out what the y value is. And in order to do that, what I'm going to do is I'm going to take the 16, put it in the original equation. The fourth root of 16 is 2. 2 times 32 is 64. So I'll have that. 64 equals 16 plus b, therefore b equals 48. And let's go back to Desmos and see if that y-intercept was 48. Oh my gosh, 48. It's magic. Hope that impresses you. It's pretty cool what we're learning here. So we saw that the y-intercept there was 48. And just in case you missed it, the equation was 1x plus 48. So this is obviously a very tricky question. And I hope that was helpful for you. Let me see if I can, okay, eraser. Let's start erasing stuff. I don't know how to, anyway, I want to clear all that, but tis what it is. I'm going to leave it like that. Let's look at this next problem. We're going to do a little bit of a warm-up here. It just says, write the equation of a line that's perpendicular to y equals 3x. So the slope would equal negative 1/3 x, and that's by memory, not by understanding. So you take the negative reciprocal. So let's go in and actually play with this for a second. Here's the number y equals 3x. So let's type something in here. Let's go 3x plus 5. Those are clearly not perpendicular. Kind of have a feeling this should probably be negative, okay, so that it goes the other way. I'm also now sensing that we should have some numbers in there. So I'm going to put a 5 in there. That didn't work. 6, 7. Oh, that's getting better. 7, 8, 9. Oh, that is looking like a right angle. And if I simplify this fraction, look at this. It's going to be 1/3, which is the negative reciprocal of 3. Let's try it again just to make sure you believe me. Here is an equation, y equals negative 4/5. So what would we need to do? Well, we need to make that a 5. Oh, and let's make that a 1. Y, oh, I have too many y's there. So we'll do this, and we'll put the 4 in there, and that sure is a right angle. So yeah, there we go. So the perpendicular of 3, the perpendicular slope of 3 is negative 1/3. So the equation of this guy right here would very simply be 5 over 4x plus just about anything. Wouldn't matter what that b value was. So that would be the perpendicular slope. And so just to make sure we're clear on that, I think we can just kind of walk through this. It's a negative reciprocal, okay? I know you know that. So the next problem requires many competencies. Here's one that you might be flexing. Developing, demonstrate, and apply conceptual understanding of mathematical ideas through probably through problem solving at this point and inquiry, because I'm going to just hope that you do your best on this. So at what point on the curve is this thing perpendicular to that? So this is a tricky question. So the first thing that we're going to do is let's sort of sketch this out a little bit, okay? So that's what I'm going to do. Here is a parabola. It looks like this. And here is that line, and it looks something like that. It's a bad line. I wish that line was a heck of a lot straighter than what I did, but it is what it is. Okay, so what we're going to try to do is find the point on this line where the perpendicular to that blue line is tangent. At what point on the curve is the tangent line perpendicular to? Okay. Oh boy, that was a really bad drawing again. I'm using a mouse here. We're trying to find that coordinate there. I think I'm going to try this again. That is not what I'd hoped for. So we're just going to try clearing the screen because that did not go well. Let's take a look at Desmos here just for a sec because they have a better graph, okay? So what I'm going to do is we're going to try to find the line that's perpendicular to the red line that's also tangent to this parabola. So it looks like it's somewhere along there. I wasn't able to draw the tangent line touching perfectly due to hand-eye coordination issues, but that's the point we're looking at. It looks to me like it's a negative x value, so that's sort of important. Here's some things that we know. We know that the equation of this new line is y equals mx plus b. We know from the previous question that the slope of this guy's slope is 1/2. So that means that the slope of the perpendicular is going to be y equals negative 2x plus b. So that would be the equation of the line, but that's the slope, right? That's the slope of it. And so what we need to do is figure out, let's go back. So we're trying to find the point on this curve that's perpendicular to this one. So what I'm going to do, again, is take my time. This parabola here, equation is y equals 2x squared. So I'm trying to figure out what's the same here. The line in the parabola would have the same slope. So I'm going to take the derivative here, which is going to be 4x. What's the derivative of this line? The derivative is negative 2. Oh, so that means negative 2 must equal 4x. That must mean that x has to equal negative 4 divided by 2, which is negative 1/2. Now, if we pay real close attention to this, and I'm just going to show you what the equation is, there's that coordinate right there. And there is, I'm going to erase this line here so we can see it plainly. There's the coordinate right there, and here's the equation of the line, which is negative 2, and it intersects at negative 1/2, positive 1/2. So if I want to figure out how to find that other x value, we found the x value of negative 1/2. If I just put negative 1/2 into this equation here, the 2x squared, we're going to get our half. And that is going to be the answer to this little challenge. So I hope that was helpful. And if you have any concerns, fill out the form and contact me. Okay. Hope it helps. See you soon.